Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of derivatives. So as per the problem, check for discontinuities in the relation and state the equation of vertical asymptote. Determine the behavior of the curve on either side of the asymptote. So the first step is to identify the discontinuities in the relation. So let's start with the one on the left side, y equals x over x plus 5. So this is a rational function, and we know that in a rational function, the discontinuities can be either in the form of a vertical asymptote or a hole. Now in this case, there is no hole because there is no common factor in the numerator and the denominator. So there is a vertical asymptote in this rational function, and the vertical asymptote can be found by setting this denominator equal to 0 and solving for x. So the first step is x plus 5 equals 0, and now we can solve for x by subtracting 5 from both sides. So the 5's on the left side get cancelled out. So we get x equals -5. So this is the equation of the vertical asymptote in this rational function, because this x value will make the denominator equal to 0. So this function has only one vertical asymptote. Now we have to determine the behavior of the curve on either side of the asymptote. So for that we can use the limit concept. So we'll have to apply the limit to this rational function to the left side and the right side of -5. So let's start with the left side. So we'll write the expression as limit x approaches -5 on the left side, and for that left side we use this negative sign at the exponent level of x over x plus 5. Now we have to find out whether this function value approaches positive or negative infinity. So for that we use an x value just to the left side of -5. So a value very close to -5 and to its left side on the number line will be like -5.1 or -5.01. So if we sub in x as -5.1, the numerator will be a negative value because the numerator is just x, and in the denominator, so we'll have -5.01 plus 5, and we will get a negative result in the denominator as well, because x is a bigger negative number than 5, and the negative over negative is equal to positive. So that means as x approaches -5 from the left side, the y value approaches positive infinity. So we'll write the conclusion after we do the test for the asymptote from the right side. So for that we can do the test as limit x approaches -5 from the right side, and for the right side we put this plus sign on -5, and then x over x plus 5. Now a value close to -5 on the right side is -4.9 or -4.99. So if we sub in x as -4.9 or -4.99, the numerator will be a negative number and the denominator will be a positive number, because in the denominator -4.9 or -4.99 plus 5 will give us a positive result. So the overall value for this limit will be a negative number. So that means as x approaches negative 5 from the right side, y approaches negative infinity. So we can write that as our conclusion. So as x approaches negative 5 from the left side, y approaches positive infinity. And then as x approaches negative 5 from the right side, y approaches negative infinity. So this is how we check the behavior of a curve on either side of the asymptote. So now we can analyze our second function. So the second given function is f at x equals x plus 2 over x minus 2. So this is also a rational function. Now rational function have a discontinuity in the form of a hole or a vertical asymptote. But in this case, there is no hole because there is no factor that is present in the numerator and the denominator. So we can just check for vertical asymptote, and for that we'll set the denominator equal to 0 and solve for x. So we'll add 2 to both sides. So the 2's on the left side will get cancelled out. So we get x equals 2. So this is the equation of the vertical asymptote in this rational function. Now we'll check the behavior of the curve on either side of this asymptote. So we'll start with our limit expression, and we'll start with the left side of this vertical asymptote. So x approaches 2 from the left side, and then x plus 2 over x minus 2. Now we have to identify the sign of the terms in the numerator and the denominator as x approaches 2 from the left side. So one value close to 2 on the left side is 1.9. So if we sub in x as 1.9 in the numerator, we'll get a positive value in the numerator, and the denominator will be a negative value because 1.9 minus 2 will be a negative value. So that means the overall value for this limit will be negative. Now we can analyze the limit on the right side of 2. So x approaches 2 from the right side. So x plus 2 over x minus 2. So if we sub in x as a number slightly bigger than 2 on its right side, so like 2.1, so the numerator will be a positive value, and the denominator will also be a positive value. So for example, 2.1 minus 2 will be positive, so the overall value for this limit will be a positive value. So now we can write our conclusion. So as x approaches 2, so y approaches negative infinity. And then as x approaches 2 from the right side, y approaches positive infinity. So there's a very important concept we need to understand and memorize. Now we can analyze the third function, s equals 1 over t minus 3 square. So this is also a rational function, and this one has no holes because there is no factor that can be cancelled out from the numerator and the denominator. So we should check for vertical asymptotes. So we'll set the denominator equal to 0. So t minus 3 squared equals 0. So we can apply square root to both sides. So on the left side, the square and the square root will get cancelled out. So we get t minus 3 equals 0. And now we can add 3 to both sides. So the 3's on the left side will get cancelled out. So t equals 3. So this is the equation of the vertical asymptote in this rational function. Now we can analyze the behavior of the curve on both sides of this vertical asymptote. So let's start with the left side. So limit x, so in this case the independent variable is t, so we'll have to use t. So t approaches 3 from the left side, and 1 over t minus 3 square. So we'll have to use a value close to 3 but on its left side. So one example is 2.9. Now the numerator will always be positive because in this case it's just a positive number 1. And in the denominator, for every value of t, the denominator will be positive because it's a square of t minus 3. So if we sub in t as 2.9, so 2.9 minus 3 will be a negative number, but when we square it, it will become a positive number. So this will always be a positive value overall. So now we can analyze the right hand limit. Then 1 over t minus 3 squared. So now we have to use a t value that's to the right side of 3, like 3.1. So the numerator will always be positive, and for 3.1 the denominator will also be positive. So the overall value will be positive. So now we can write our conclusion. So as t approaches 3 from the left side, y approaches positive infinity, and as t approaches 3 from the right side, y approaches positive infinity. So this is the behavior of the curve of this rational function on either side of the vertical asymptote. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.